All right, so we're going to talk about even and odd functions. So we've been talking about functions like their characteristics and their intervals of increase and decrease and positive and negative. And today we're just going to talk about another way that we can analyze a function. So one way is to tell if the function is even or odd. So let me just draw a picture of what an even function would look like. That would be an even function. And an odd function might look like this. So the main idea is that an even function has this mirror, or this line of symmetry that's right at the x-axis, and an odd function has symmetry around the origin. And so let me show you what that might mean. So the symmetry of graph, the symmetry is about the y-axis, whereas the symmetry here is about the origin. Okay, so here's how we can check that. If I plug in negative x into an even function, the output is the same, right? But if I plug in negative x to an odd function, we get the opposite. So let me show you what that might mean on a graph. So let's say this point here on an even function is 5, 5. If I plug in the opposite of x, which is negative 5, I should still get the same output, which is 5. So you can see that these points are reflective about the y-axis. But let's say I have the point 5, 5 on an odd function. If I plug in the opposite, I will get the opposite y value. And so that's kind of the main idea here. So let's see how we could test this with the equation. So something could be even, odd, or it could be neither. It could be neither could work. All we do here is we plug in negative x. So if I plug in negative x to this function, I would get negative x in the absolute value plus 4. But negative in an absolute value will just end up to be the absolute value of x plus 4, which happens to be our original function. So because when I plugged in negative x, I ended up with my original function, this is even. All right, what about this one? Let's plug in negative x into our g function. Okay, so I would get negative x to the 5th plus negative x to the 3rd plus negative x. Well, if I have a negative 1 to the 5th power, then that means I'm going to have a negative 1. Negative 1 to the 3rd power will still be a negative 1. And so look what I can do. I can take a negative 1 out, and I have negative 1 times my original function, which is the same as negative to the original function. Oops, and this should be not f of x, this should be g. So because when I plugged in negative x, I got the opposite of our original function, this is called odd. Okay, so you can probably guess that this last one's going to be neither, but let's see. If I plug in negative x into my h function, if I square negative 1, it becomes positive. So you can see that this is not, that does not equal our original, so it can't be even. But it also does not equal the opposite of our original, right? It's not like all of the signs have just changed like they did here. All the signs were just changed. So this is neither, because neither of those patterns ring true. So you can kind of start to make some inferences about like what happens with the powers, like is it going to be even, odd, and you can kind of, you'll notice some patterns with these sort of questions. But that's it for even and odd.